looking to incorporate CRAN in some way, shape, or form. Also aquatic chemistry, and trash. In terms of response metrics, what available data there is for the watershed are benthic macroinvertebrates, algae, also fish communities, and aquatic dependent wildlife. And by aquatic dependent wildlife, mostly referring to wildlife such as your amphibians, reptiles that are really dependent upon the stream systems. So I said this is a watershed approach, but one of the first things, I'll explain a little more detail in a second, that was a challenge was that for the San Diego River watershed, it's kind of difficult to consider the watershed as a whole. And if you look back and look at stream restoration, river restoration science, it really should be done in a regional context of the system. And so we decided to do that for the San Diego watershed as well. This is the San Diego River watershed. Lower section down here is anthropogenically sandwiched between San Diego Bay and Mission Bay. The upper end of the watershed extends into the top of the coastal range in San Diego. Elevations top out about 6,000 feet. And in terms of looking at the watershed as a whole versus subregions, I'll point out right here, this is the major breakpoint we found when looking at the data and working with the stakeholder group. These are the two major impoundments, San Vicente Reservoir and El Capitan Reservoir. And they basically capture the upper portions of the watershed. And the other thing that you can see on this map, which is great, is there's some pretty clear divisions in what the stream systems and stressors are in the watersheds. So the lower portion of the watershed is extensively urbanized, lots of stormwater discharges. There's a live stream sewage treatment plant discharge, lots of urbanizing pressures. The upper portion of the watershed has lots of open space, over 70% open space, lots of reference type conditions. But I'll point out that in between a lot of these gray areas, there's a lot of rural residential agricultural development. So it's not too surprising to realize that most of the monitoring goes on down here, where all the dischargers and regulated parties are. There is some monitoring that goes on up here, but it's mostly looking at reference site conditions or federal monitoring that's occurring on federal lands. So one area where we very quickly identified was that this in-between section, this rural residential agricultural, was being missed. So this is what I would call an opportunity and a challenge. So there's a lot of stakeholders in the watershed, over 21, and there's lots that do monitoring and are interested in monitoring. And this turned out to be actually great. There's a lot of data available, so it's going to be up to Brock and other folks to actually integrate it. So great. Not my problem right now yet. But we have active NGOs. We have the San Diego River Park Foundation. They do lots of monitoring. The lower watershed, they do extensive invasive species plant monitoring, actually do GIS-based mapping of all the invasive species. We have citizen monitoring groups like San Diego Coastkeeper, San Diego Stream Team that do water chemistry and bioassessment. San Diego State University has long-term monitoring stations for water chemistry and flow. We have the Regulated Community Stormwater Monitoring Coalition, cities and counties that do a lot of bioassessment in the lower watershed and reference sites in the upper watershed. We have federal agencies that are interested and active in the stakeholder process, primarily USGS and the US Forest Service. And then we also have California Department of Fish and Wildlife from a fisheries perspective, and some water supply agencies, Helix Water and Padre Dam, and the city. So this figure kind of shows one of the initial inventories of where monitoring is occurring. It kind of highlights this regional disparity. Not only does this show, one, that there's lots of monitoring occurring in the lower watershed, but two, when you look at the upper portions, it's really limited. So you can see in this blow-up of the urbanization, or the urbanized portion of the lower watershed that there's lots of different scales, lots of fish community sampling, lots of invasive species monitoring, but when you get, say like above San Vicente Reservoir, it's pretty limited. A couple bioassessment sites tend to be targeted. Some of you in this room I know have probably sampled those sites. So this was one of the challenges we first found. I mean, it's a challenge, but it's actually good information because we know where some of the data that's needed to do assessments is lacking. So we considered the urban and the upper watershed to be just different entities for the purpose of looking at the data and coordinating monitoring. So in terms of alteration metrics, we have good physical habitat in the lower watershed. The aquatic chemistry sampling and monitoring has been extensive, mostly associated with stormwater, so extensive water column, sediment sampling. Invasive species monitoring has been really good in the lower portion of the watershed, as I mentioned before. And there's also good coverage for trash surveys from the NGOs. In terms of response metrics, benthic macroinvertebrates, algae, both good, associated with the bioassessment. Fish communities, there's good coverage. And you notice there's an asterisk here. So this is one of our first challenges. So we're working with fisheries biologists from Department of Fish and Wildlife, and they're looking at fish communities in the lower watershed. So one of the first challenges we came across is, well, the lower watershed, the fish communities are all invasive species. So it's kind of an alteration factor too. So how do we handle that? Because if you say, oh, we got a really diverse fish community, well, Fish and Wildlife said, we don't want to say that because it's non-native species. So there is some value, the work group agreed, there is some value to knowing what the condition of the fish community is, even if it's non-natives. Because, for example, say there's a huge sewage spill in the lower watershed, and there's a big impact on multiple trophic levels. It's useful to have that information to put it into context. Now, in terms of aquatic dependent wildlife, it's pretty limited data in the lower watershed. Some of that's resultant from the non-natives that are prevalent, but there is some data associated with the parks and habitat conservation plans. Now, in terms of sampling, the lower watershed, I've been lucky enough to partake in those efforts. There's some challenges to working in the urban environment to try to get this data for multiple metrics. This is in the lower portion of the San Diego River. It doesn't really look like a river, does it? It's more of a pond. So the work group kind of struggled with how this is really a river, but there's been so much modification in some places. How do we actually, include waters like this where it's technically moving, but it's not really suitable for using your existing things like stream bioassessment. Another challenge has to do with some unruly residents of the river. So this is actually a boulder-sized snapping turtle that we caught up in a fight net when doing fish community surveys. Wasn't too happy. But there's also, in the lower watershed, there's a pretty extensive homeless population within the river. That can make doing sampling and safely an issue. So we actually generally worked with partners when doing that. Lots of them we found have lots of dogs, which makes safety a big concern. Then there was a bit of a philosophical discussion in the work group and looking at data from really engineered creeks. This is Forester Creek, which drains the city of El Cajon, which is